Thank you, and welcome to Misreading Human Emotions. This panel is part of the program for When Machines Dream the Future, a hybrid festival on living with artificial intelligence organized by the German Hygiene Museum and Goethe-Institut. Our audience is joining us both in person from the Hygiene Museum in Dresden, Germany, and online from all over the world. So after I introduce the speakers and the subject, two of our panelists will present their art-based research projects on facial and emotion recognition technology. And the panel will discuss the promise and peril of emotion artificial intelligence and its applications. Then I'll open the floor to questions. And if it's possible to switch to people's images, can you see all the panelists? Okay, good. Alexa Hagerty is an anthropologist and researcher in the field of science, technology, and society studies. Her work centers on the social impacts of forensic and biometric technologies using ethnographic, co-design, and art-based methods. She is an associate fellow at the University of Cambridge, Leverhulme Center for the Future of Artificial Intelligence, and a senior consultant for the Just AI project at the Ada Lovelace Institute. In collaboration with designers and researchers at Cambridge University and UCL, she developed Emojify Info, which is an interactive, serious game that demonstrates how computers can scan facial expressions with the claim of detecting emotions. Jessica L Tracy is professor of psychology and a Sauder School of Business Distinguished Scholar at the University of British Columbia in Vancouver. Her work is currently funded by a grant from the Social Sciences and Humanities Research Council of Canada. She's a social and personality psychologist, as well as an emotion researcher. Her work primarily focuses on emotions, especially nonverbal emotional expression and the emotions of pride and shame. And then Mushon Zer-Aviv is a designer, lecturer, and media activist based in Tel Aviv. His works and texts investigate how the interfaces of technological culture are reshaping politics, design, and networks. He's an honorary resident at the I-Beam Arts and Technology Center in Brooklyn, New York, and teaches digital media as a senior faculty member at the Sankara School of Engineering and Design. His online artwork, Normalizing, questions our visual perception of social normality through portrait photos, social systems, and automation. And then serving as moderator, I'm Devin Schiller, a cultural semiotician. I'm the recipient of a doc fellowship from the Austrian Academy of Sciences, and I'm currently doing my doctorate at the University of Vienna. My research focuses on emotion recognition-based biometric art and the semiotic temporalities of facial behavior. So today, the use of techno-labor for extracting data capital from facial behavior is accelerated. More and more corporate, governmental, and institutional organizations employ facial recognition. And indeed, the actual and potential areas of application are considerable. Applications include, for instance, augmented and virtual reality, consumer marketing, film and game animation, healthcare systems, lie detection, human-computer interaction, law enforcement, military perception, smart environments, and social robotics, as well as what I have termed biometric art. Stakeholders therefore have a vested interest in facial recognition, not only for pure research, but also for applied research that addresses real-world problems. Consequently, face databases and face data have become a commodity. In response to this clear and present societal need, technology companies then economically compete to innovate better and different approaches for achieving facial recognition through artificial intelligence, machine learning, and computer vision. And of course, facial recognition technology and automated facial expression analysis have a long history. These cultural practices and their technological processes advance from classical physiognomy to modern anthropometry to contemporary biometrics. But since the mid-20th century, the research and development of facial recognition technology in North America, Europe, as well as Asia, has been a combined public as well as private endeavor, shaped to a significant extent by military objectives. But by the late 2000s, however, almost 40 years after the first public exhibition of facial recognition technology at the 1970 World Exposition in Japan, facial recognition became available as commercial software that non-expert users can configure into large-scale applications. As we'll experience during this panel, some of these applications play with facial recognition technology. Some subvert. Some celebrate the accomplishment Some critique the arrogance. Some put it on stage, and some on trial. Now, emotion as well as affect recognition are specific types of facial recognition. And at least on the face of it, emotion recognition technology can be useful for making visible the outside physiological behaviors of the face, and in turn making knowable the psychological phenomena inside of an individual by computing a person inside out into data that is operational, universal, utilitarian, and quantifiable. Known as emotion AI, automated facial expression analysis falls under the category of effective computing. But the computation of emotion on the basis of face depends first and foremost on the concept that is being used for what an emotion is and what it does, such that emotion recognition applications can be crucially differentiated by their predictive model and data template. Now, operational functionality for most, if not all, emotion recognition derives from the facial action coding system, or FACS, a semiotics-based technique for the comprehensive description of all visible facial behaviors, which was designed by American psychologist Paul Ekman, and then as well as basic emotions theory, which he, among others, advocates. Basic emotions theory has three principal tenets. Firstly, that the facial expression of emotion is phylogenetic and specified through biology. Secondly, that prototypical facial expressions of particular basic emotions are more or less universal across cultures. And thirdly, that there is a causal link between the outside physiological behavior of the face and the inside psychological phenomena of the emotion that produces it. Now, even in the face of wide critique in the behavioral and brain sciences, the computer sciences have researched and developed emotion AI on the grounds of basic emotion theory. Even so, emotion recognition technology is neither good nor bad, nor is it neutral. Whether and to what extent this technology is applied successfully, let alone justly, is entangled with the logic that makes it operational. Now, this technology is used principally for doing predictive analytics. However, such data behaviorism poses complex ethical dilemmas, in part because the focus is on abstract models rather than real agents, real people. Of course, the face has long been used for putting people into boxes made from diagnoses, labels, or symptoms. But an important aspect of what is lost in this datafication of the face is the possibility for rigorous scrutinization into how political languages and power relations become integrated within recognition technology. For example, all too often, facial recognition often depends on the same logical fallacies as physiognomic inference, such as presuming a relatively stable one-to-one, almost binary, correspondence between outer facial behavior and inner emotion phenomena. And this in turn can result in an abuse of face. Just in October, for example, the European Parliament called for a ban on facial recognition in public spaces. Now, given this facial ethos within its Orwellian phantasm and panoptical overwatch, this panel explores the ways in which there's far more to the use of recognition technology in society than meets the eye, and how its machine-generated technical images cannot and should not be taken at face value. So now I'd like to introduce Alexa Hagerty and her project, Emojify.
Oh, thank you. What a wonderful, thought-provoking introduction. Thank you to the organizers, and I've really been looking forward to this conversation. So I'm going to start by just taking us on a whirlwind tour of Emojify. So let me start my screen share. And here we go. Oh, okay. Well, we can't do that. Okay. So Emojify is a project that I was part of with I led with an incredible team of people who I'll show you at the end. Designers, researchers, citizen science experts. And what we wanted to do is really open up the conversation around emotion recognition technology to everyone, to anyone. I really love Joy Buolamwini's quote that if you have a face, you have a place in the conversation. So our aim was to create a series of serious games, some of which use an actual emotion recognition system that you can interact with on the site. That we paid a lot of attention to setting up very securely and privately so it collects no information. We don't even use cookies on the site. To explore the social science behind emotion recognition, to think about what its potential and actual consequences might be, and to just open up a space of conversation and reflection. So this is where you land when you go to Emojify. And sadly, working on our shoestring budget, it doesn't work that well on all phones and all tablets. So I hope that you will use a laptop to try it out. And I hope you will try it out because it is actually more fun to play games than to talk about them. So first you get to a screen where you can immediately turn on the emotion recognition system if you want to. And play around with it. And you can watch a short animated film that just talks about a little bit, just gives you a little taste of some of the controversy around basic emotion theory and some of the uses of emotion recognition systems. And one of the points that we wanted to make with the sort of this informational component was to think about how maybe emotion recognition isn't really the right word, because recognition supposes a kind of knowing, but instead what's happening is a kind of facial tracking, a tracking of people's expressions. So I'll just play you just a teeny clip of the film, mostly so you can appreciate this beautiful animation.
Is emotion recognition technology emojifying you? What if we told you that tech companies are creating artificial intelligence to read your emotions? Well,
okay, well, it already exists. That's I cut it off too early. Well, it already exists. So then from here, I put a few other, these are some screenshots of the animation. So here you get to move into the fake smile game and play around. And the idea here is that you try to make the emotion recognition system register one of these 6 basic emotions. But of course, as you're moving your face around from happiness to sadness to fear to surprise very rapidly, your inner state isn't probably changing. Unless you're a really good method actor, your inner state isn't changing. And so here we can open up this kind of disconnect between what's happening on our insides and what's happening on our outsides. And this is something that I think all humans have extensive experience with if you've ever faked a smile in an uncomfortable situation, but which machines can't register this difference. And here is some screenshots from Kazuhiro Taira, a professor of media studies who wrote an article on Emojify. And I think that he wins the prize for just the most wonderful expressive faces. And then when you play the game, you win the fabulous prize of being told you have a great fake smile. We also have a game that's a wink blink game that you don't need to use the emotion recognition system for. And this we're drawing here on the work of anthropologist Clifford Geertz and his very important idea about the difference between a wink and a blink. That a wink and a blink are both the eye closing, but that one is a social signal that's telling you that something's going on, and the other is just a reaction to like having dust in your eye or something. And for us humans, it's quite easy usually to know the difference between if someone is winking at me, telling me, oh, there's something going on under the surface here, or this is a joke, or I'm putting a play frame around this, than if someone has dust in their eye. So it was to draw attention to the difference between winking and blinking and our spectacular abilities as humans to know the difference. And finally, we asked people to share their thoughts through a series of questions. And here, I think what's particularly important is that we gave people just a text box just to write anything that they wanted to write, any of their ideas and insights through a series of question prompts. So there hasn't been actually a lot of work done on how people's perspectives on emotion recognition, but most of the work that has been done with Likert scale. So where a researcher proposes a question and then the person taking the survey says, okay, I really agree with that, or I agree with that less. But we wanted to do something that was more open-ended and really let people share their thoughts and feelings. And we got thousands of responses that we're still analyzing. And what has really impressed us most is the nuance and the complexity that people bring to this space. So I think that, our feelings about emotion recognition technologies as a society are multiple, and people hold many, many ideas. So this is something that's an incredible resource. And there's a real hunger. People have a real hunger to participate. That was the other feeling that we got from this project. So, so then just a thank you. I'm here, but it took many, many people with many talents and backgrounds to bring Emojify into the world. And this was, actually such an exciting project, and it's multidisciplinary collaboration. So that's my little whirlwind tour. And again, I hope that you'll go visit the site for yourself and play the games.
Fantastic. Thank you, Alexa. And Mushon, if you would also then introduce your normalizing machine, and certainly the video first if you choose.
Yes, thank you.
Thank you.
Thanks, Alexa. That was great. Let me just share my screen now. Sharing my screen. Okay. The normalizing machine is presented as a scientific experiment. We're trying to teach machines how does a normal person look like. Machines only know normal. If it's not normal, it's a deviation from the norm. For us, we actually work the other way around. We identify when someone is abnormal. Participants are asked to step in front of a camera, and then they're presented with two portraits. They're asked to point at the one that looks more normal. That portrait stays, and then the next one is entered in, 5 rounds like that. At the end, they have to compare between themselves and the most normal portrait. And after they do that, the image is added to this wall. The machine creates categorization of different segments of the face: the eyes, the ears, the nose. And it tries to understand what is a normal nose, what are normal eyes, what are normal ears. It was important for me to make a physical interaction because we have a body. Our eyes are within our body. When we are looking, we're also being looked at. And when we are analyzing, others are analyzing us as well. This is very different than computer vision. Computer vision is vision without body. And that really changes the whole idea of vision and communication. In the 19th century, the police in France started to use photography to document criminals. But then when they would arrest someone, they wouldn't know if he is who he says he is. Alphonse Bertillon was a French police officer and forensics pioneer. And he invented the mugshot, that picture that we all recognize as the picture of criminality. He also created this table, which he called le portrait parlé, the speaking portrait. If the person would not speak, their face would speak. He categorized it, so if this person has this kind of nose or chin or whatever, you look for them in this folder. For him, it was an indexing system. It was replaced a few years later by the fingerprint, But the people who actually continued using it was the eugenics movement and later the Nazis to try to identify the perfect human and to prevent people who are not perfect from recreating. So they took natural selection and Darwinism as a prescription rather than an analysis. This whole thing went underground after World War II, and now we're seeing this come back through machine learning and face recognition and computer vision. So I wanted to put this whole conversation about algorithms in a historical context. How do we actually deal with the idea of normality? How do we actually categorize and being categorized back? How does that change when we're changing to different technologies that look at us differently and we can't look back at them?
So, so this is the normalizing machine, and since 3 weeks ago, I actually launched a new version of the piece, which is called Normalizing. And what we thought of doing is actually allowing you to try it out. So this time, the work was commissioned by Science Gallery Dublin as a web-based piece. And it's following pretty much the same logic and the same background as the normalizing machine, but this time happening completely on your phone. So if you're interested, feel free to simply scan the QR or just write normalizing in your browser, your mobile browser, and you can try it out right now. The interaction takes about a minute and a half. So, so I encourage you to give it a try.
As you're doing that, I will tell you that this is how the piece looks at the moment at the Science Gallery Dublin in an exhibition titled Bias. There's a phone connected to a selfie ring, the type that Devin was talking about buying maybe recently, and that image is mirrored to a display screen. On the other wall, you can see the output screens, the cards, and a map that maps the different faces. Now I'm going to switch to the browser to possibly see your contributions as they come in. So what we're seeing now is what we would have been able to see on the two screens in Dublin. You can see that every participant, the many green backgrounds are from the gallery in Dublin. So when you see a green background in the map, that means it was taken in Dublin. It's also mentioned on the cards themselves. But what we're seeing right now actually is how the map clusters faces by similar facial features, and which creates kind of a disturbing clusters or kind of racial clusters. So we see the Asian cluster, and we just saw the darker skin cluster, and you'll be able to see clusters of males and females. And it's interesting to see what the machine decides to separate as
as a cluster, and we can already see the kind of biases of what is a general face for the machine. The frame widths indicate the level of normality. So we can see that this is a 0.6 normality score. So it's a bit thicker than others. And the thinner ones are considered less normal. I think I would let, at some point we'll start to see your faces in this in the screen, but I think in the interest of time, I'll skip. I think I'll stop sharing my screen at this point, and we'll continue. Thank you.
Wow, fantastic. Thank you, Mushon. Thank you both for demonstrating these fascinating art-based research projects. Now we can start integrating them into our discussion for the whole panel. So I'll start with just some questions, but then we can continue as we go forth. And then again, for the audience afterwards, we'll come back to you, of course, and can respond to anything that you're curious about. So starting with you, Alexa, what does your art-based research project Emojify info teach us about the role that the context of an interaction, as well as the relation between individuals within a given context, plays in facial behavior and emotion phenomena? And how and to what extent do you think emotion recognition that uses artificial intelligence either succeeds or fails to address this interactional contextuality and interpersonal relationality when detecting, extracting, and classifying the facial expression of emotion?
Yeah, thanks for that. Really rich question. I think that so much the context is such a big part of what we need to be thinking about when we think about both about emotions and also about these technologies. So, I'm an anthropologist, so I am thinking in terms of groups and communities and societies and thinking about emotions in these social contexts. So think, for example, about how when we are in different situations, we express emotions differently because there's a societal expectation that we express emotions differently. So if I'm in a job interview, or I'm on a date, or I'm being questioned by the police, or I'm at a wedding, these are all would have different expectations for the appropriate way for me to express my emotion, which I have learned throughout my life, and also to interpret someone else's emotions in those settings. So that's something that at this point, machinic intelligence isn't really able to do or to take into context. It's really looking at the face in a vacuum. And I'm really interested to hear more from Jessica Tracy too about the psychological perspective on this. But I also think about emotions in terms of relationships, because let's say that if we are with a friend who's feeling down, or we're in a crowd that's cheering for a team, that we also have a way in which our emotional life is connected to the emotional lives of the people around us. So that's another thing I think we have to think about. But finally, I really want to think about the context in which these technologies are used. Because as Mushon pointed out in the film, these are used in political contexts, in social contexts. These are not used only in labs or in a kind of vacuum. So, we do live in a world of inequality or unfairness or differential levels of opportunity. So what does it mean to have these kind of technologies interact with the world? And in that way, we might want to think about not just emotion recognition, but facial recognition technology or other forms of technologies. There's many. There's gait recognition. There's vein patterns. There's many ways. There's many biometric technologies, ways in which people can be identified. And what this means, in situations of, for example, political instability, or there could be the transfer or capture of these kind of technologies. We've seen this recently in Afghanistan. So just end and pass the baton to others, because I'm so curious to hear others' responses too. But I really love something that Deb Raj, who's an important AI researcher, has said, which is that there's two ways that facial recognition technology is talking about specifically, but there's two ways that technologies can cause harm. One is by not working well and being discriminatory, and the other is by working perfectly, but working in an imperfect world. So those are all the levels of context that I think we need to be thinking about when we think about emotion recognition.
Yeah. Jess, Mushon, you want to continue on that thread, or?
Sure. Yeah. I mean, I think, thanks, Alexa. That was really, I agree with all the points that were made. Just to say, my background is in emotion expression recognition, and one of my, Paul Ekman, who kind of started this field, was one of my advisors early on. And so from a research standpoint, I think this stuff is great, that, his method for reading emotions from the face has really advanced psychological science in emotion, and our understanding of emotions and so on. But research works really differently than the practical applications that have been used for this stuff, right? So when we use these kind of automated systems to infer emotions from the face, we're doing it in a large scale kind of way, right? Where you take a large sample of people and you make an assumption on average, if someone is showing certain muscle movements in their face, on average, there's a likelihood or a probability that people who show those particular muscle movements are expressing and therefore feeling a given emotion that we can infer based on the associations that have been documented. But that only works when you're looking at a large group of people, right? Once you take that and say, okay, well, then I'm going to infer that this one particular person in this one particular moment, that their facial behaviors mean they're feeling something, we can't really do that, right? Because you're taking a probabilistic understanding and applying it in a way that's just not accurate, right? So if just because on average, when people smile, it means they're happy, it doesn't mean that any one given person who's smiling is happy, for all the reasons Alexis said, the cultural differences, the situation, the societal stuff. And of course, we can control most of our facial expressions, and we do all the time for many, many reasons that vary by situation, by person, and of course, by culture. So I don't know how, the people who are using these applications in practical, real world ways could possibly take that into account. That's not kind of my, that's not my domain. But yeah, I can see enormous problems if those issues aren't taken into account.
Yeah. I particularly enjoyed the syllogistic reasoning you highlighted when the large data sets then get applied to the individual, that you then get these assumptions. Mushon, do you?
Yeah, I think one of the topics that I think, one of the kind of overarching themes that that our conversation is a part of is this idea of datafication. Like, how can we turn phenomena around us to data and then analyze it in tools that are convenient to us technically. Like it's almost mind-boggling how simple that idea is. Like the world is complex, and it's not it's not functioning according to a language that we can process. So and we've come up with a language starting with numbers, and that's where the examples of Bertillon and the datification of the face and the body that started almost 200 years ago are actually very, very key. Very, very key to understanding where we are right now, and I think this tendency towards datification is and this really understandable interest in knowing more faster, knowing more efficiently, knowing more in a more in larger scale,
often doesn't have enough patience for the outlier, or even for what does it really mean. And just before the beginning of the session, we were trying. I think some of you were already inside the room. We were trying to think of a theme song, and indeed, I didn't think about it before, but eyes without a face is really what we're talking about. These are machines that have eyes but don't have a face. So Billy Idol, of course, for the millennials in the room, and the Gen Zs and under. But yeah, this idea, when we talk about emotions, we talk about kind of a play between communication between faces in a lot of cases. It's often not the case where somebody has emotions expressed alone in front of a camera without a face on the other side until recently, right? And I think that's the historical context. I think is really important for us to understand where we are in time, and what are these technologies trying to do. I'll stop here. No.
Yeah. Thank you. Maybe just a brief question to combine those last 2 points. I mean, if Ekman's facial coding is integrated into some facial and emotion recognition, but emotion recognition itself is then used in these very different contexts. Maybe, Jessica, do you think that technology has very valid uses within the laboratory? I mean, not laboratory per se, but within a research context.
Yeah,
and then
I do.
When you take it to the grant, I mean, optimizing time, hand coding is almost impossible. I mean, from a time standpoint, almost impossible.
Yeah, right. Exactly. Yeah. So, I mean, in my lab, we definitely do work where we code nonverbal displays and make inferences about emotion from that. And I have a grad student who does it by hand. He was trained in the system, which requires like 500 hours of training and then like a 30-hour test. I mean, it's enormous. And then doing it, it's just enormously painstaking work. So these automated systems are hugely beneficial. And of course, we are looking at large samples and we're not making inferences about any one person. We don't really care about diagnosing or inferring emotions about any one person. What we care about is, okay, well, in this situation, in this, experimental setting, when people are placed in this situation, on average, do they tend to show this expression? And if they do, we're going to say, okay, then the given experimental condition induced the emotion that we thought it would. We can make an inference from nonverbal behavior. And of course, ideally, when we measure emotions, we never just use one indice, right? Because nonverbal displays are one thing. You have feelings that people can self-report. You have cognitions. You ask them about their thoughts. There's all different ways of measuring. And this is just one tool of many. So in that sense, it is useful. That said, it's not infallible, right? So I think one thing that maybe sort of Alexa was getting at is that these tools tend to take into account face only. And we know that emotions are conveyed through much more than the face. The body is really important. Head movements are really important. Voice is really important. And you lose a lot when you look at just one set of behaviors. Just to give you an example, my former grad student has done this really cool work. His name is Zach Wittkauer, showing that when you tilt your head down, if you have a neutral facial expression, you look threatening or angry. So let me see if I can demo it. I'm probably not doing a great job here, but basically what he's found is that the angularity of the eyebrows, which we do when we're angry, you can see I'm doing that now, that happens. Yeah, Mushon's doing a great job. That happens, or that appears to happen when you tilt your head down, but you're not actually moving your eyebrows, right? So it's this really cool kind of visual illusion that occurs. And we found that it's a way that people express dominance. They basically are conveying threat to others just through a head movement without actually doing anything with their face. Now, it's a really effective and strong signal. If you show that to people very reliably, they say, oh, that person's dominant, that person's threatening, that person's intimidating. However, if you show that head tilt down facial expression to a machine, and Zach did this, the machine says neutral, just neutral, no anger. because the machine is very good at reading facial muscle movements. And in fact, there is no facial muscle movements. The machine's correct, but it's not correct about what's actually going on within the person, which, is a great example, I think, of how the machines are not perfect, right? And we need more than the face, and we use more than the face to convey our feelings.
Certainly, or the sun's just in our eyes, and we're trying to get, there's so many of those context factors. And I think more and more systems, at least in the laboratory, but also in applied context, are integrating the multimodal aspects of emotion. I know some integrate, for example, Affectiva, that's a facts-based emotion rec, is now integrated into software that also does gaze and body gait analysis. Mushon.
Yeah, so this really reminds me of a point made by John Durham Peters in a book from the end of the 90s called "Speaking into the Air," and he's a media theorist, and he was talking about the problem of communication as being between two extremes. One extreme is telepathy, basically being able to know everything that goes on inside one's head, the other's head, and the other end is solipsism, this idea that no one can ever understand me, and there's no actually way of even knowing if I exist, right? So the two extremes, he argues, are extremes that are not desired, but what he calls a mediation, which is what media does, is constantly kind of negotiate and kind of moves between these two extremes, never really getting close to them. But if we put face recognition and then face analysis and affect analysis, emotion analysis on that continuum, we see that there's this pull towards telepathy, right? Towards the idea that we'll be able to know what you think even if you're not necessarily interested in telling us, and that becomes that really opens the discussion about like what is like to what degree do we control these barriers of the mind, right? To what control is mediation something that happens to us, or something that we do that is kind of more negotiated? Yeah, I feel like, especially with the discussion about even more ambitious technologies like Neuralink and all this field of like reading minds directly, it kind of begs the question of what did we kind of lose the ball on what mediation is supposed to be doing?
Yeah. I'm just going to squeeze in a few more questions amongst the panelists, and then let's open it up to the audience. They're starting to get some comments in the chat thread, and then also possibly on site, though I can't see that. Alexa, coming back to you for a moment. You work with both interdisciplinary centers and laboratory contexts. I mean, in terms of, so much of this technology is developed through military protocols and through political motivations and for those uses. I mean, even the original grants that I think Ekman had renewed for over 40 years were from DARPA and some of those same organizations working in an interdisciplinary context. I mean, here we've got simply anthropologists, psychologists, media activists, semiotician. What do you think that interdisciplinarity has to teach the study of face and emotion, or how these things are developed and deployed?
Yeah, I mean, I think that we are moving in, we desperately need interdisciplinary work. And I think, as we all know, interdisciplinary work can be really hard. I mean, even between disciplines, we may use terms like bias very differently. We may have a very different idea of what something like prediction means. So even to learn to talk to each other can be difficult, but we desperately need to do that urgently. We have to do it now, because these kind of technologies really do cut between and beyond disciplines. So, I mean, I think that we will see the emergence now of new disciplines where people are trained in really kind of critical social science and in more technical fields. And I think that that will help, but it won't, I think that we do have some of that going on now, where we have like embedding philosophers in computer science programs, which I think is great. But on the other hand, you're not going, no, just like you couldn't send me to a coding camp for a weekend and I'd pop out on the other side and be able to solve these problems. We're not going to solve the problems by, giving people some crash courses in philosophy. But these are truly interdisciplinary problems. So, yeah.
I mean, Mushon, very generally speaking, you have sort of a media art type approach. I mean, art that is both drawing from an artistic framework and also the scientific and technological framework, and is working on both levels. And you've shown you're normalizing in a number of countries by now. I mean, I saw it in Austria. Now it's online, of course, but then Germany and on. So often in the public discourse, or even in sort of the knee-jerk reaction, these technologies are looked at as this sort of dystopian, Orwellian, eye in the sky, overpowering framework, sort of this technophobic aspect, or in this utopian-esque, technopositive way. I mean, what do you think that both art and art-based research, can bring into how these things are conceived, what features are developed?
Yeah, I think, I for once am not, I don't feel like face recognition, machine learning, all of and bias in kind of what's called the algorithmic bias is a problem of AI. It's a problem of society. It's systemic bias. And systemic bias is something that we've had as long as we had, systems, right? And the technological systems that we started to deploy more and more on top of social systems, or like Alexa mentioned, they work well in an imperfect world, right? It's and what I'm excited about actually is that we're talking about it, because systemic bias has been a problem that was much, much, much less sexy before it was wrapped in these high-tech these technologies and these kind of concerns about human agency and are the machines going to take over our lives. And all of a sudden, systemic bias is a central topic of discussion on Wired magazine and the likes. And I think it's a great opportunity. So there are kind of contradicting streams, if you might. Like, one is indeed that these technologies are going behind the scenes into black boxes. There's more alienation between those who actually write the algorithms and the effects of these algorithms. And I'm talking about algorithmic bias in general here, but definitely the more we kind of stray towards the telepathy end, right? But at the same time, the fact that this is becoming more and more of an interdisciplinary field, it means that more disciplines are having their say. More disciplines, and including computer science and communication and sociology and anthropology and psychology and so on and so on. Like, we're having this interdisciplinary discussion, which I would want
to remind us should be about systemic bias, right? And then like how do we use these technologies, understanding that systemic bias is a problem that we're facing, and now should we normalize it? And that's why I'm using this this terminology of normalization, which is baked into the technology, right? These statistical technologies are about understanding what to expect, what is normal, where is the bell curve, and what is probably noise or something we can ignore. So there are things in like outside of the bell curve, outside of the realm of the normal, the social normal, that we should not ignore, right? So we need to kind of balance how these technologies work.
Yeah. I think that's both absolutely essential. And thank you. It also segues just quite organically into some of the questions we're getting, if I might just continue this thread. But for each of us, feel free to jump in here, even all at once. I don't know if there are also questions on site, if we can see that, but at least in the chat, Claire's asking about efforts by Charcot to identify psychiatric diseases with drawing and photographs of mentally ill. That's not a study myself I'm familiar with, though I am familiar with how photography was used sort of in Freud's era to not only identify, but actually model, to conceive of what is mentally ill. And then also how performativity fed back into those photographic processes. And then of course, Lombroso as the father of, quote unquote, father of contemporary criminology. It's contemporaneous with Sherlock Holmes with those kind of writings. And fiction took extraordinary facial depictions that he was then claiming were essentially the mental ill characteristics behind or driving criminality. And then he also looked at tattoos and art making practices incorporated with that. But in terms of Charcot's and today's efforts, Mushon?
Yeah, I think I'm not familiar with that specific work, and I wrote it down because I want to familiarize myself with it. But I really think that that this, again, ties into this wider attempt to look to use science to look at society, right? So the idea, social science is a term that we're very familiar with, but it's worth thinking about what does it mean, or even the idea of like, as I was working on this piece in the early stages of the work, we presented it in Jerusalem, and we translated it from English to Hebrew, and in Hebrew, normal as we say normally, which is obviously not a Hebrew word, but Hebrew is a special language that way because it's hasn't been used for 2,000 years. So some words had to be borrowed, but then when we translated it to Arabic, I got a few suggestions for translations, and none of them seem to work. So the official word that is being used is tabai, and tabai actually means natural. So and normal and natural are definitely not the same thing. And if there's something that my work is trying to do is to talk about that. And then there was another secondary word that actually meant regular, and regular is also not normal. And apparently, you would say, like, how come Arabic doesn't have a word for normal? Well, the reason for that is that normal is actually not a very normal word, and it's kind of new. Normal is a word that just appeared around the Enlightenment, and it was used exclusively in scientific context until around 150 years ago.
So the idea of social normalcy is really, really new. And it's the idea of science influencing the way we look at the world, right? That's what science is supposed to be doing. But then we get with science and through language, kind of a baggage of how should we look at the world, right? Should we look for the normal and then categorize the abnormal? Or the Greeks did it in different ways. They had an ideal, and then the ideal is something that you can't really reach, and that's fine. So it was the outlier that is the benchmark. And we can think of other benchmarks or not having a unified benchmark, right? Science may need a unified benchmark, but it's a question for the kind of relationships that we want to build in society.
Yeah. Just because we only have a few more minutes, I'm going to try and address some of the other questions raised in the chat. Maybe Jessica. Lisa has a question about higher view, which is also a system that I'm not familiar with, and how it's combining face recognition, speech analysis within an interview context, but shifting now, leaving that and focusing on the sentiment analysis. Certainly I've seen a number of emotion recognition systems used in interview contexts, but to my understanding, sentiment analysis is a keyword-based system. So that's a dramatically different turn, and therefore more, in a semiotic sense, more in a symbolic level of analysis. But Jessica, what do you think?
And that's interesting. I haven't heard of that program, but what I would say is that I think every way of measuring emotion or feeling from people's behavior, all aspects of it, is going to provide some piece of information. And as an emotion researcher, like I said, our goal is always to use as many forms of measurement as we can. So in my work, I do look at nonverbal behavior. I also look at, I guess what you're calling sentiment here. We've done work for a really long time where we have people talk openly or write openly about their feelings. I've done work, for example, with recovering alcoholics, where they come into the lab and talk about the last time they had a drink while video recorded. And this is a great example because we're getting their nonverbal behaviors, which we then code. We take transcriptions of what they actually said and we code them. And we do this with humans because we don't have the automated, but they're automated systems. If we want sort of basic positive emotion, negative emotion, there's automated systems that do that. Typically, we want things more like, to what extent do they feel shame? To what extent do they blame themselves? So we have a team of undergraduates typically who read what they wrote and code for these themes. And that provides really useful information. In that particular study, we also have them provide saliva samples throughout the course of the discussion. Yeah. And so we then send those off and we can get measures of cortisol reactivity, right? Which is another measure of stress. And so, this is just an example, but like in the ideal study, what we want to do is measure emotions with as many different tools as we can, because there is no single indicator, right? You can't say, oh, well, they're showing this in their face and that means that for sure. That's one piece of information, but what they say is another, what their physiology says is yet another. And so I'm all for this. I think the key thing is just to not focus on only one, as opposed to kind of taking everything in combination and seeing what that tells us.
I do know about this higher view case, and higher view is just one of many companies who have been using a number of technologies in the interview process, and they're really these companies really do believe that this will be a way to overcome social bias, to overcome social discrimination, and to give people who may have been shut out of certain jobs access. So it's an interesting theory, but I do think it's quite problematic. And I think that actually higher view and many companies like it also take, in some ways, are doing kind of what Jess is talking about, which is they're like, okay, well, we're not just going to take one data point. We're going to use many, many forms. So now it looks like they're phasing out voice too, but they'll use many different forms of biometric and other kinds of technology to try to have this predictive role about how people perform in jobs. But I think this is also really problematic, because it's one thing to be collecting all of this kind of data and information in a lab where we're trying to understand human beings more deeply, or social, our societies more deeply, but it's another thing to be using them in startups. So I think that we have to think about what are the aims of these technologies and what are the incentives and motivations. Because as long as we are working, this is part of the imperfect world, that we are working under these constraints, then I think we have something very problematic that we're dealing with. But it looks like we might be ending. So I'll stop there.
It looks like we might have to wrap up rapidly in seconds. So thank you.